Hello, hello. It says we're live. Let's see if it's actually working. Laura will tell me if it's not. Welcome to the Squirrel Squadron and our event this week on why non-coders, people who are not technical, should read code. So if that's what you came for, you're at the right place. If you wanted to talk about something else, go somewhere else. That's okay with me. Let's see. So some of you might not know what the Squirrel Squadron is. That's my community. I'm Squirrel, by the way. It's my community of tech and non-tech executives. We're getting up toward 3,000 now around the world, every continent. I mean, we don't have any penguins. Sorry, nothing in Antarctica. But people around the world talking about how to make tech insanely profitable. So I was just hanging out over on the forum, and my friend Roland was just commenting on an exciting topic we were discussing recently about outputs versus outcomes. You know, people ask me all the time whether I can give a speech or do a session on something or teach their team a particular technique. And I always say no. And then they say, what do you mean? You do that all the time, Squirrel. And I say, but wait a minute, you haven't told me what the outcome is. You haven't told me what the result is. So we had a great conversation about that. Roland had some good ideas on that topic. We have scrolling down on the bottom some of the things that we're talking about and the ideas and topics that are coming up in future events like this. So forum is, by the way, all this stuff is free. It's my way of giving back and keeping in touch with the pulse of technology and non-technology, how they're working together. So we have upcoming events, which are very exciting. I'm going to focus on just one, which is a live in London event. I'm going to get to other parts of the world soon. I was in New York, Berlin, other places last year. I'm going to try to get around to more locations, maybe even Nigeria. I've got some clients there that would be very exciting to visit. But the one that's coming up now is in London, near where I live. And what we're going to be talking about there is how to gain a whole extra day in your calendar every single week by turning down the volume, making sure there are fewer meetings, fewer Slack messages. You should delete Slack. That's a nice controversial notion. We're also talking about that specific topic, why Slack is evil, in a couple weeks on a free live stream. So exciting stuff coming up. All of this is free. I hope you find it exciting and stimulating and provocative. The main thing I want to know from you guys is, are you a coder or a non-coder? And either way, what made you decide to come along and talk to me about this? So a number of folks maybe who couldn't be here have sent me questions ahead of time. So I'm going to be answering those questions. But as veterans will know, I love it when people interrupt, when people disagree, when they toss things into the comments. I wish you all could talk to me. I hope we'll figure out some way to do that soon. But in the absence of that, use the comments on whatever forum you're looking at me on, and give me a quick note now. Who are you? What made you come here? And are you a coder or a non-coder? Because I can tune a little bit for the audience there to make sure to help non-coders feel brave and stick their toe in the water and read some code and understand what the engineers are doing, and help the coders to help the non-coders. What could you do that would help the people in the organization actually read your code? And why should you not be terrified of that? So tell me that in the comments. That would be very helpful so I can tune this to you. If you don't, I'll just talk about whatever I feel like, which is totally fine as well, because I'll have a fun time. All right. Now, what I want to do is start with a story, and I have to obscure the story a little bit, but not very much. Not very much, excuse me. The client came to me and they said, Squirrel, we don't know what our product does. And I about fell off my chair. I said, how could you not know what your product does? And they said, well, look, we know basically what it does, and we keep selling it to people. And what it basically does is it reviews videos of what people are doing. I have to obscure that part, exactly what they were observing. So they're observing the videos. And in those videos, maybe a safety violation occurs, something dangerous happens, and we need to alert people in real time. Yo, danger here, danger Will Robinson, red flashing lights, and so on. And so we do that, and people buy it, and they like it, but sometimes they say, hey, this safety issue happened over here, and we didn't get an alert. And your marketing says you monitor for this safety violation. What gives? Why haven't you actually alerted us? And folks have asked for proof, and they said, do you actually monitor for this? Do you monitor for that? And the client, the CEO, came to me and said, I'm actually not sure. I said, how could you not be sure? Didn't you go ask the engineers? Well, it turned out there was a breakdown in communication. The engineers would keep saying, oh, yes, it absolutely does it. Don't worry. It's all fine. Everything is there. But the CEO had more and more doubts. He kept saying, I don't know, we get these reports and we're not sure. And, you tell me that it does this, but how could I know? And I said, well, actually, there's not so hard a way to find out. And I told him about what I'm going to tell you. And I also did an investigation. So I went and had a good look at the organization, looked at the code, talked to all the people, do a lot of this evaluation, sort of a health check for people. And so I had a good look, and I was able to go beyond what I'm going to teach you guys, because it turned, and you might have the same kind of opportunity. That's why I'm telling you this story. So this totally non-technical CEO actually had a team who had created a bunch of automated tests. Now, if you know me, you know I love automated tests. If your team doesn't have automated tests, stop everything, go have them write automated tests. But these guys had gone above and beyond. What they had created was a library of videos, and they made them in various clever ways so that they triggered the safety alerts and so on in certain cases and not in others. So, if somebody walks by, that's okay, but somebody walks in front of something they shouldn't, or goes in a place they shouldn't, it's going to alert and tell you safety violation, danger, Will Robinson. And they made these videos, and they had the system actually look at the video, give an alert or not, and then they checked, did it do what it was supposed to? So they had a whole bunch of these tests. They were running every day. They were running all the time, verifying that the software did a certain set of things. Of course, there was other stuff that the marketing people maybe had said, hey, we do this cool thing. There wasn't any test for it. No guarantee that the software does that, right? If you're not testing it, you don't know that it's actually happening. And so I said to the CEO, why don't you go watch some of those videos? And he said, what a great idea. I'm an expert in this area. I really know about the safety issues. I know what should show up on the videos and what shouldn't. I had no idea that my team had these fantastic automated tests with videos that I could review. And he went off and he had a good look at the videos, and he said, marketing folks, you got to stop saying that we do A, B, and C, because we only do X, Y, and Z. Now, actually, we do X, Y, and Z really well. He gave a lot of feedback. They worked on improving the tests and so on, so they could really claim they did X, Y, and Z. They've been claiming they did stuff they didn't, which was quite dangerous, right? You're going to get sued or cause a safety issue or something else. So it was very, very valuable for that non-technical person to go and look at these videos, which were the automated tests that verified that what the software did. And that's the main thing I'm going to advise you. Your software may have nothing to do with videos and safety and all this other good stuff, but your engineers, I guarantee, have something, or if they don't have it, it's really dangerous and you should take care of it right away. They have something that verifies what they do, and you can go read it. So that's what I'm going to teach you about today. But let me stop and take some of the comments. We have Stephen, who says he's a manager that codes. Excellent. David is a coder, starting a team leader role next month. Excellent. So David, you can do a lot to bridge this gap. We'll talk about that. Sven is an agile coach, that not a lot of coding. Great, Sven. So you're a person who can read the code and encourage others to read it in the way I'm going to teach you. Oh, and there's Niall, my old friend. Fantastic. Niall is a coder and a non-coder and an expert on everything and local language and HIPAA and FedRAMP and everything. Niall's my go-to person for anything compliance related. So wonderful to see Niall here, and make sure that the security people and the people he works with converse with developers. Hallelujah, Niall. I'm very glad you're doing that. You're doing God's work there. You should teach everybody to do that. We have a wonderful crew here. All right. So very good examples. Thank you everyone for putting those in the chat. By the way, we have people who are watching this on a recording. So of course I'm not, you can't respond if you're in Australia or something and you're sleeping while I'm talking and you're watching this later. I appreciate that. If you have questions and concerns and thoughts that come up while you're on the recording, head on over to the Squirrel Squadron forum. That's right down here below wherever I'm pointing, and make your comments and questions there, because I'm very happy to respond. We have great discussion going on all the time there, and lots of folks who are experts, not just me, who might have suggestions and ideas. Great. So Stephen, David, Sven, Niall, you guys all feel absolutely comfortable typing in questions, telling me I'm wrong, jump in wherever you like. And I really appreciate you've given me a bit of a steer for what audience we have. We have a nice mix, as we always do in the squadron, coders and non-coders and people who are both, and folks who can think about this question. Okay. So I'm going to give you the bare bones basic situation that I guarantee anybody can read and get information about what their engineers are doing anytime in any software organization. Then we're going to talk about some of the fancy stuff that you can do. So we'll do the basics, kind of playing scales, if you're learning keyboard instrument. And then we'll start arpeggiating and using the pedals and that stuff. We'll start doing the fancy things. Here's the very basic thing that every non-coder should do with every engineering organization under the sun. Ask 2 questions. Question number 1, do you have automated tests? Now, many organizations, sadly, 20, 30 years after we really got going with automated tests, still don't have them. And that means, just in case you're not following what I mean by automated tests, there's nothing inside the computer as the developers write code that says, hey, hang on a second. I'll use Stephen because he's a manager who codes. Hey, hang on a second, Stephen. You wrote some code here that doesn't work. In the safety example, hey, wait a minute. It's supposed to detect this. It used to detect it, but Stephen, you broke it. So stop, Stephen. And then Stephen very smartly says, hang on a second, I broke something. Rather than release it, I'm going to go fix that before I actually get it going. Now, you may have people who are in quality assurance. They might be called testers, different folks like that. Those are very valuable people, not denigrating them at all, but they're doing a human job that a computer could do, probably with a lot of their time, if there are no automated tests. If you have automated tests and manual testers, you got a great combination, because the people can be creative in the way the computer can't. They can say, oh, wait a minute, what if we did it backwards? What if we did it upside down? What if we did negative numbers? They can do a whole bunch of cool stuff that'll help developers catch errors. Good, so keep them. But what you want to do for this exercise of understanding what your engineers are doing and whether they're doing it right is first ask, do they have any automated tests? If they don't, stop everything and go have them write some. A really good place to have them write it down is get that quality assurance person to write down what it is they actually do. They may have some scripts. They may have something that they already use. They might have created some automated tests to automate their work so they don't have to bang on the same keys in exactly the same order in the same way. Anything like that you can find is valuable. And you want to get it automated so that it runs every time any developers, I keep picking on Stephen, anytime Stephen makes any change, he can run the tests and he can say, this was a dumb change. It broke this thing. Then you can say, I made a better change. Actually, it made this thing better. Excellent. I'm going to ship that. Now we can put it live in production. The benefits of doing that are huge, and I could go on about them, and I'll tell you more if you want. If you have questions about that, why is this so valuable? I'm very happy to tell you. There's 3 or 4 vital things and about 100 other very useful things that automated tests do for you. One of the things it does for you is make it completely auditable. And this is your second question. Once you find out there are automated tests, completely auditable by any human being anywhere to find out what this software does. Because imagine that you wanted to know, what's happening in a factory. Well, one of the things you might do to figure out, all these people running around conveyor belts, all this kind of stuff. Actually, I'll use slightly different example. I worked with an Australian mining operation, so I got to know all about mines recently. I'm not an expert on any of these things, but it's fun to learn them. So the mine has, conveyor belts with the ores in them, and they have sorters and filterers and people who dump the stuff into vats and then put the vats on big lorries, and the lorries drive around. So they have all this complexity. But there are simple things that happen at various stages that let you check that the mine is actually mining whatever it's supposed to. So you can say, how many gold flakes did we get at this station? How many bits of rubbish, tailings that we don't need? How many of those come out of the mine, and how's that compare to the actual ore that we're trying to get out of the mine? All that kind of stuff. Those are the tests. And a good mine will have those tests automated. They'll have some kind of station where something is monitoring that kind of information. This is one of the things I was helping the mining operation to improve and keep that data so they can say, whenever that squirrel guy, he brings a load of coal, it's not very much coal. It's mostly rubbish and rocks. That squirrel guy, he doesn't know what he's doing. He's scooping up the wrong stuff. You can tell how expert I am in mines. But the point is that there's an automated system. There's something that gathers data. And if you want to know what the mine does, you could find that out. You can say, we're trying to get this percentage of coal. We're trying to get this percentage of this other ore. We're trying to make sure that our tailings only weigh this much and that we put them in the right place. Whatever they care about, you can tell that by looking at what they measure. Same things for your engineers. If your engineers are focused on a particular set of outcomes and they've created automated tests that verify those outcomes, then you can check that. Now, how on earth can you do that? I hear you say. So some of you are saying, hey, wait a minute, I never wrote a line of code in my life. I don't know binary. I'm not sure what all those ones and zeros mean. You know, how am I going to read that? Here's a secret. You don't have to read the lines of code, because what the engineers should be doing, and the second question, so the first question was, do you have automated tests? Second question is, show me them, sit next to me and show me what they look like. And what you do is you read the names of the tests. Now, sometimes engineers, because we're engineers, we're geeky, you know, people who love numbers and maths and zeros and ones and all that kind of stuff, we give really bad names to our tests. We call them test 1, test 2, test A, test B, test C, test user, test feature, test bug 1237. These are bad names for tests. But if you find out your engineers have bad names for their tests that you can't read, wonderful, what a great result. Because now what you can do is say, please stop and do what you're doing. Go and write meaningful names for these tests that I can read. And at 2 o'clock, I'm going to come back and I want to read some of these tests. I want to read the names of the tests, and I want you to explain what they're doing to verify those things. So let's stick with the mining operation. What you might do if you want to automate tests for the software that runs the mining operation is you might run a test that says, measure, this would be a good name for it, measure a percentage of small rocks. Not sure what the right mining term is. Measure the correct percentage of small rocks versus large rocks after the filtering process. And that might be a piece of software that's actually measuring that, and you want to make sure that gets stored in the right place. And for example, it stops the mine running if they aren't getting any small pieces of material, because that means they're shaking or their filtering upstream is not working. So that might be the sort of thing that you want. I just made that up, but you've got the idea. And you could read that test and say, we're measuring something about the small output, the small rocks that are coming out of the mine. And you can verify that it actually does the right thing. How do you do that? You say, wait a minute, Squirrel, I can't read the code in the test. Somebody writes some test in a programming language. I don't read a programming language. I want to tell you a great story. This story is apocryphal. I don't think it's really true. But, you know, in computer science departments in universities, this joke was at least familiar when I was doing maths and computer science at Berkeley. And the joke goes like this. Not a very funny joke, but it makes a good point. One professor turns to another and says, you know, what's your favorite programming language? What do you really like to use when you really want to get a great answer, you want to get fast results, you really want to work well? What programming language do you use? And at that time, it would have been, you know, C or C++ or COBOL or something like that. And the other professor turns around and says, my favorite programming language is graduate student. And the answer there is, of course, you're turning to somebody who knows much more about the thing than you do, because that professor is probably not a great programmer in modern programming languages, but can turn to that junior person and say, you explain it to me. You figure it out. You write the code. Same thing. You got engineers, and you're sitting with them. Remember, I said, you're going to show me the code. You're going to show me these tests. I'm going to read the names, and then I'm going to turn to you, and I'm going to say, how do we measure these rocks? How do we measure their size? Well, we have the computer vision, and it measures this, and it measures that. And you say, show me some examples. How does that work? Wait a minute. What happens if we have different colored rocks? What if we have different ores? What if this happens? What if that happens? You can apply your knowledge of the industry in the domain you're working in to those tests using the graduate student, i.e. the developer is sitting next to you. Now, by the way, some developers are going to say, stop bothering me, just let me write the code. I can write it faster. If you quit sitting next to me all the time and reading the tests and so on, this is irritating. I can't get stuff done. You wanted it done this week. I can't do it if you keep slowing me down. Your answer is great. I'd like you to slow down, and I'd like you to work on the right thing so I can actually tell what you're building so you're not building the wrong thing. So my marketing team isn't off marketing the wrong stuff, right? The value to the company is very high of an activity like this. And by the way, it doesn't have to be, say, the CEO. I told in my example story there, I said the CEO went and watched the videos. It doesn't have to be. Easily delegate that to somebody. But what you want is a domain expert, somebody with a lot of knowledge, providing lots of feedback immediately on the spot to the developers saying, you didn't test for the large rocks. You got all the data you're gathering on the small rocks. We care just as much about the large rocks. So go off and build some tests for that before you build the next feature. Right? Because you haven't measured the important things here. You haven't verified that you're doing the right thing. Okay, I see a bunch of comments. I'm going to go deal with some of those. But I hope you've got that basic idea. 2 questions. Do you have automated tests? If not, run away and write automated tests. Once you have automated tests, can you show me and can you talk me through what these actually do? We'll deal with some of the issues there as well. Goodness gracious, loads of comments. Now, I can't always see who's saying this. So we got somebody on YouTube says, applications are really complex and difficult for a non-developer to read. I agree. Fantastic. You know, this computer vision system that was doing the safety checks, you know, world-class, fantastic engineers building this very complex stuff to keep people safe. Really, really valuable and really complex. But it was doing stuff like, notice when a person is standing on the left side of this thing, and if they're on the left side, do this, and if they're on the right side, alert everybody because they shouldn't be on the right side. It was that kind of system. And if you can't explain your system in those terms, you got a real misunderstanding of your system. So I predict, YouTube user who has automated tests, good to hear that. So I predict that there's an easy way to describe, a comprehensible way for people who use this system to understand what it does, why it does that, and for them to measure whether it's doing the right thing. Assuming that's true, that's where you use your graduate student. You use your engineer who's sitting there, who does read the code, and says, you know, I don't know. Does it do the left side or the right side? I don't know. Ah, it doesn't do either the left or the right. It seems to be confused. There's a bug there. Great. We found a problem. Okay, YouTube user, I hope that was helpful. I don't know who that is, but I'm glad you're asking good questions. And my dog agrees as well. My dog's about to go on a big walk. So you may hear the dog barking in the background. She's 5 months old and full of energy. And I bet she would like to read some code. She could. Well, maybe. I'm not sure what her understanding of business domains are and whether she'd be capable. But you can for sure. Niall says, large applications often are, once someone knows with some code experience knows where to look, they can get benefits from their understanding of the code. Now, that's more advanced. Niall, I'm going to come back to that. If I don't, please remind me. That's where, with some help often, you can get somebody who is not an engineer to understand parts of the code in a really valuable way. There's a bunch of different stuff about that. And you've reminded me about something called a DSL, which I should remember. So help me remember that. I've written it down. Steven says, a boss from way back once briefed us on a new project heading our way. He rounded the meeting off with, and I don't care how you build it as long as you write the blanking tests. I've lived by that since. Excellent. Steven, I appreciate that. That's really valuable. What you may not have got from that boss is that boss actually reading the tests and helping you to say, wait a minute, you built the test, but you built them wrong. And that's what I'm advising you to do now, is to not only build the blanking tests, but also make use of them with people who are not coders. So let's see if I'm provoking anybody. I want to see if anyone's disagreeing with me. Niall says he doesn't know how the code is laid out, but he finds his way to the place that he wants to look at. Great. David says, now, this is very important. David says, replace graduate student, as I was saying, the developer who might help you, with ChatGPT. Now, this is really valuable and really new. So, David, I'm glad you brought this up. I was going to cover it later, but I want to come to it now because you pointed it out. There are some ways you can get around this because we start to have pieces of software that can actually have conversations with us in the same way the engineers can. There's some danger with this. So I'd be very cautious about actually trusting the the bots, ChatGPT, Claude, Gemini, all the others that are out there that can have conversations with you about code. I wouldn't do that myself, even with my level of technical knowledge, which is high, and I certainly wouldn't recommend that for a CEO or a CFO or somebody like that who might have less without an engineer sitting there to help. But you certainly could have the conversation and then say, could you just look over this? Is it telling me the truth? It says we don't test this. And the engineer says, yeah, it's confused. It doesn't know. We do it in a kind of funny way. We do this, 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 and this. And you say, but did you think about that thing? So, David, you're absolutely right that pointing any of these code analysis tools with large language models at a bunch of code, engineers can do that for you. You don't need to do the technical part of that. So you point it at that, and then you just get a chat window. And you can say, hey, do we test for long passwords? Do we make sure people have good passwords? Yes, we have a strength test. Great. What kind of tests do we have for that? Do we test for the right number of characters, the right types of characters, whatever the rules might be that you might have expertise about? You can have that conversation. But please, for the love of God, have an engineer actually verify that the thing isn't lying to you. I'm not as worried about hallucinations. The better term for that is confabulations, where it just kind of makes up stuff. I'm more worried about it getting confused. because what these tools are is junior developers. They're really, really unskilled developers, but they're capable. They're kind of bright and energetic. They're really fast, and they are able to do basic stuff. But you give them anything complicated, they really do go south pretty quickly. I'm going to be writing something on this, by the way. There's a preview on the forum, and I hope to do it in one of my weekly emails. So I forgot to mention, we do a weekly email as well with lots of exciting stuff, new directions, and new ideas. I write one of those weekly for the forum, for the squadron. And one of the ones coming up is going to be about, I'll just give you a preview, the software atelier, ATELIER. So watch out for that. That's how you should be using these AI tools, with a senior engineer leading a bunch of junior engineers, graduate students, AIs. So good tangent there, David. Really exciting stuff. And you're absolutely right, but be cautious. My main advice here is you don't worry about the ChatGPT stuff. Let the engineers do that. Go get them to explain to you what the software does, and then you can explain to them what it should do. That's really, really useful to get that domain knowledge passing back and forth. Okay, so we got the basics. We got fantastic questions. This is loads of fun, good stuff, and we'll get to lots more questions. Please keep putting them in. This is really good. Now, we've got some non-technical persons sitting down with engineers and reading tests. Now, one thing the engineers might try to show you, which I want to kind of warn the engineers about, and the non-engineers to not do this, is that there's a type of code, a type of writing tests called behavior-driven development. Great method, very, very valuable, really good stuff. Not something that necessarily captures the information that we're looking for here. Sometimes it does, sometimes it doesn't. But it's kind of dangerous. So I would be cautious about over-relying on it. I would make sure that you understand what the test actually does. What BDD does is it says, and you might have seen these kinds of things from your engineers if they use it. It says something like, as a user, I want to read the report on sizes of rocks in our filter system so that I can tune the filter system. And that gives you kind of a piece of what the test does. And then there's an actual piece of code that goes and does that stuff that's written down. The problem is that the interface between the English words that somebody's trying to write and what the test actually tests ain't that good. So often there'll be a test that says all that good stuff, and it doesn't actually do it. And so I'd be very nervous if you were saying, oh, yeah, we do a bunch of behavior-driven development. We don't have to do any of that stuff because we read our stories. The standard tool for this is called Cucumber. The language that people use for it is called Gherkin. If you're trying to get non-engineers to write these kinds of tests, that really doesn't work. Even when you read them, it's not fantastic. There's nothing terrible about it. Don't panic if that's what you have. But I would focus on what the names of the tests are. What do they actually do? And if the engineers have named them badly, you've discovered a problem with the engineers. Go fix that. Once you fix that, you have a bunch of tests that are being executed every time anybody makes a change, and you know that the system does what it says it does. This is one of the great benefits of automated tests. It gives you live documentation that can never go out of date, because every time a developer changes something, the tests go and run, and they say, yeah, I still did what I did yesterday. Oh, wait a minute, I didn't do what I did yesterday. Stop. Maybe I meant to make that change. I can update the documentation, namely the tests and their names. Or I can actually leave it alone, fix my code, and then the software will keep doing what it used to do. Either way, I've got up-to-date information about what the software does. Okay, now let's move on to some slightly more advanced stuff, and then I'll turn to some of the questions that I got ahead of time, or more questions from you guys. Really good stuff in the chat here, folks. Thank you. So a more advanced method, Niall reminded me about, is actually to create something called a domain-specific language. And if you've got clever senior engineers, they may already have one. Now, there's an old saying, and I can't remember quite whose it is or where it comes from. I'll look it up and put it in the forum. But the saying says that if your system gets sufficiently complicated, I think it's Greenspun's law, I think it's Philip Greenspun, but I'm not sure, then your code will contain a very bad copy of something called Common Lisp. Doesn't matter what that is. But it'll essentially contain a domain-specific language. It'll contain the ability to parse things that people type in and convert it into action. Now, if you've ever used Microsoft Excel, you have seen something like this, because if you type in a formula, that's in a little language. And you've probably learned stuff like that if you use it, equals sum parenthesis, blah, 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 blah. And there's some if, so you can sum things only if they are credits and not sum your debits and all that kind of stuff. So Excel's pretty clever about that. And it has its own little language in there. If you use Microsoft Word, it doesn't have that. Actually, it has it kind of hidden someplace because it's a sufficiently complicated tool, and therefore, according to Greenspun's law, it has this somewhere in it. But people don't know about it very much. It's not hugely used, whereas in Excel, people use it all the time. If your software has something like this, then you can do some of the stuff that Niall's referring to. He says, I don't really understand how it all works, but I can kind of dig around and go in here, and I can say, I don't think the passwords are long enough. I don't think this is going to pass FedRAMP Rule 67C subsection Q because it doesn't do this, that, and the other thing. And sometimes people have kind of hacked together domain-specific languages. It's not as nice as what's in Excel, and you can't kind of go and learn its grammar and look up the pieces of code that are really made readable by it being written in this way. But there's like sections where you can make out what's going on, and the engineers can really help you. Even if they don't create a full domain-specific language, they can format the code in a nice way. They can comment it. They can put more information in it. They can make it more readable. There's lots they can do to improve your ability to check some complicated bit of logic that's happening in there to say, well, if it's Thursday, then make sure you have the small rocks, but not on Friday. Or if the moon is full, then you have to do this other thing. That kind of logic can be written in a way, either in a domain-specific language or in something close to it, that you can go and check, or an expert can go and check. And again, that's tremendously useful. The engineers spend a little more time making it readable. It helps them too, so it's actually very useful that they do it. And you get the opportunity to verify that the software does what it's supposed to. Oh, David found it for me. Any sufficiently complicated C or Fortran program, you can tell how old this is, from old languages we used to use back then, and still do sometimes, contains an ad hoc, informally specified, bug-written, slow implementation of half of Common Lisp. And the Common Lisp part is a technical part. What it really means is you can write programs in this thing, and it's ugly and horrible and evil unless you've paid attention to that. So if your system's pretty complicated, been around for a long time, you probably have this, and ask your engineers, where's that piece? Refer to Greenspun's law. Oh, the YouTube person is Franco. Hi, Franco. I think I might know which Franco this is. Very nice to see you there. It's not a matter of reading code, but knowing the domain and checking the results of the code. Almost. It's not only the results of the code, Franco, it's also the meaning of the code and what it actually does, the behavior. And I'm not expecting you to go and read the code to discover that, except if we've done these extra things like domain-specific languages. I'm going to mention another one in a moment. That kind of thing that engineers do to make it more readable, they may not. Franco is actually thinking, if you're the Franco I think you are, I was thinking of your system specifically, being very old, having loads of cruft and ugly stuff and patches on patches on patches. That's going to be hard for you to follow. Don't worry about it. You have graduate students, you have engineers. You sit them down next to you and you say, okay, engineer, tell me what this test is that you've told me about. It says that it verifies, if Franco's the one I think he is, he's in the shipping industry, so I'll shift to that. It verifies that we've maintained the bilge pumps on in the back of the ship, in the aft section. We've maintained them in the last year. And here's how it does it. It verifies this, and it checks that, and it does the other thing. And Franco says, yeah, but have you verified that we've not only maintained the pumps, but cleaned them? And I'm like, what do you mean clean them? Well, that's not something that we're supposed to verify. And you say, yes, it is, because Franco knows this industry, and he knows maintaining ships, and so he can describe that. I hope it's the right Franco. I don't. If it's not Franco, I'm sorry, but I'm sure you'll follow what I'm saying. That you want to check not only the results of the code, what is the output, what's the report, for example, that you're checking, but what are you checking? How does it do it? How does it create it? What does it do? So absolutely right with that one addition. Okay, I hope that's helpful, Franco. Right, now I want to show you something. Now I hope I can actually succeed in doing this. I'm not always good at that. So if I do this, and I do share screen, don't show me the tips, just share the screen. And what I want to do is find the right one. So this may take a moment. Sorry, I have way too many tabs and things open. I want a window, actually. Oh, can I not do it? Oh, it may not let me do it. Let me try it a different way. Apologies. talk amongst yourselves for a moment while I work out how to do this. That would be over here, and yeah, it should be there. Okay, let's see if that works. What I'm going to do is show you something that my team created years ago, and not enough people use this this method. What I just need to find is where it is. Where'd you go? I have too many tabs. That's my problem. Why won't it show me? Arg! I even have it right here on the front of the screen, but I can't actually look at it. So it'll be, I'm going to try one more time, see if I can find it. No, that's not it. Well, that's annoying. It won't do it. Okay. Well, I'm just going to try to describe it to you. Let's see if I can find the example another way. If I do this, will it help? I don't think it will. I'll just try it. I apologize. I thought this was simple. Yes, I found it. There we go. Beautiful. Okay, so this is a tool that my team built, might be 15 years ago now. Yeah, 2010, there it is. This is a method you could still use. And I just want to illustrate, because it goes right to Franco's point, well, actually even Niall's even better, that there are things you can do to make tests more readable. So here's a test of a very basic piece of functionality. It adds two numbers. Most computers should be able to add two numbers, right? So, and I hope you're seeing this. Laura, I hope you'll wave at me if for any reason this isn't showing up here. I think it is. Yes, it looks like it is. And I'll switch back over there. There we go. So if you're going to add two numbers, you might just read that part. That's what I told you about first. That was the basics. You must say, well, why are we adding two numbers? We should be subtracting them, right? You can have a very useful discussion just about the name. But you can also, if the developers write it in this way, and this is related to behavior-driven development, by the way, they say, given this, in this situation, when this happens, then do this other thing, similar to the 3 steps of BDD that I mentioned. But that doesn't matter. They've just written down that if the operator has pressed 2, and then pressed plus, and then pressed 2, this is a calculator, I guess, and then press the equal button, then you got a 4. What a surprise. And that's a very basic type of test, but that's the sort of things your engineers should be testing. Test the basics and then test more and more complicated things. And they can write their code in a way that you can actually read. It looks like English. Now, don't try to write this stuff yourself. You'll add all kinds of error messages and all kinds of things will go wrong and so on. This is pretty painful. And AI is not up to this yet. To write in this, it's called a narrative style. And this is an old library called narrative. You probably shouldn't use this specific one, but your engineers could do something similar. So if you really double down on this, if you really want to get good at this, and Niall sounds like he's done some of this, so at least he understands where his engineers have hidden the secrets that he needs to get to, and he can drill in to find it. In that same way, you can get your engineers to make your tests more readable in a way that's like this one, if it's important. Now, there may be tests you don't care. You just want to read the name, and you just want to verify it does the right thing. But if you want to invest more, you can get a domain-specific language going. You can get this kind of narrative-style test, or depending on your domain, there may be something specific to your domain, like the example I described at the top, where the team actually had videos. So you could go watch the video, see what it does, and say, what's the test expecting? Expecting an alert. Ain't no alert here. Something's wrong. This test isn't doing what it should do. Or we should alert differently, or we should do this different thing. There are lots of different ways that you can get your engineers to share the information that they have about their code. Okay, so let me stop that. Okay, success in that domain. Let me look at questions, because I got a bunch of these from you beforehand, and I want to make sure to cover some of those. Please keep them coming in the chat. That's a fantastic place to put them. But I'm going to switch to some questions that came in ahead of time. So, not sure who this is. Sebastian. Yes, Sebastian's. Ooh, come back, Sebastian's question. There we go. Is reading code useful when starting as a product manager in a new company? If yes, which part? Well, Sebastian, I hope I've answered the which part. That's the test. Start there. If the engineers have no tests, run in fear. No, tell them, go write tests right now. You're the product manager. So you can say, hang on, stop doing what you're doing, do tests instead, because you're going to save so much time. They're actually going to be much faster if they actually write some tests. That's what I tell all my clients, what I've seen in 25 years of coding and technical leadership. And is reading the code useful? Absolutely. It's a great way to learn about what the software does. And some really good clients of mine have actually had reading some of the code, working with the engineers, being on an engineering team, as part of the onboarding process for new joiners. And they'll say, look, go sit with the engineers. And they say, oh my God, I'm in customer service. What do you mean you want me to talk to engineers? They're geeky and strange and they speak Klingon. And you say, get over that. They're friendly. They know how to, you train them, of course. They know how to show you interesting and valuable parts of the system, and they'll show you what our software does, not only by showing you on the screen, but showing you what they actually test, what they verify, and how it works. And often that person will then contribute something because they'll think about it differently. They're coming from the outside, and you'll get better tests as a result too. So, Sebastian, I hope that's helpful. I absolutely endorse very strongly reading code as a new product manager, as a new customer service person, as a new salesperson. People who are not in the software team should read code. Specifically, they should read the tests. Franco says, how long will it take the non-developer to understand code? 0 minutes. And the reason I say 0 minutes, Franco, is because the kind of coding that I'm encouraging you to do, to read, is the code that is the name of the test. And I've given you specifics. I just want to review this in case anybody missed it. What you first do is say, are there any automated tests? If the answer is no, get them to write some. And if there are automated tests and their names are terrible, get them to write reasonable names. That's something that they can do if they understand what the software does. If they don't understand what the software does, we're all in trouble, right? So as long as you understand the domain, which, Franco, if you're the right Franco, I think you do very, very deeply, then you will be able to understand meaningful test names. And you can keep going back to them and saying, this isn't meaningful enough. This isn't helpful. You're not using the domain terms. This is what you should be, the language you should be using. And once you get to meaningful tests, they will have better understanding of what the software does. And you can read the names and get them to explain. So I hope that's helpful. Stephen says he's always enjoyed working with RSpec. That's a particular behavior-driven development tool, if I'm remembering my tools right. He showed some specs to non-coding QAs once, and they were able to understand what it does. Fantastic. So RSpec is in the Ruby programming language, which is particularly kind of friendly to this narrative style. You can mess it up. You can make it more difficult. I'm not going to expect non-coders to read reams and reams of code, pages and pages, screens and screens of complicated software language. That's just not their thing, and I wouldn't expect them to. But they certainly can read the names of the tests. Shouldn't be anything stopping people. And Franco says he's the right Franco. Excellent. I've correctly sussed out who it is I'm talking to. Always very valuable. Let's see. What are our other questions? So we had Lucian said, is it, okay, great question from Lucian here. Is it feasible to make comprehensible even the most abstract parts of the company's code, covering key processes? All right, so again, we're getting into a more advanced area. Good, that's exactly what I wanted to cover. And what can happen, this is greater effort. It's not just read the names of the tests now. Now we're going to be starting to understand some of the logic. We're going to try to understand and format for non-engineers pieces that are really valuable for them. And I'll just give you another trick in this direction. I've mentioned domain-specific languages, writing the code in a narrative style, formatting an appropriate logic section. Another trick for this is actually just to call out inside the code. So the code is doing various things. If you ever looked at any code at all, you know it has stuff like if this, then do that thing. That's kind of the great breakthrough of computers, right? Is they don't just add a bunch of numbers. They add numbers only if they are equal to something else. We've seen that in Excel, for example. What you can do is call that out, format it in a way that actually makes it visible and comprehensible. So what you can do, if you do some extra effort, is make sure that it's clear what the logical flow is. You could even make a flow chart and put it next to the code. Now, the fancy name for this kind of stuff is literate programming. So you're actually putting the documentation next to the code that it documents. And so you can read through the two of them together. This really makes most sense for non-coders, when you've got really complicated, convoluted ways of deciding what to do. You know, I worked with a client who helped people figure out which page of the manual to read because the piece of machinery that the manual was for was so complex. The software would actually read the manual and say, read page 97. That's where your error is. And so you need to, you know, pull out the widget and plug in another hose or whatever it was. Those are complicated industrial machines. And so the software was following a very complex logical tree. But you could write down the tree. So if you've ever seen a doctor do this, you might have had the doctor do it with you, or you might have seen a diagnostic tree. What it says is, first, does the patient have a headache? Okay. Yes, patient has a headache. Okay. Are the patient's eyes dilated? Does the patient have, you know, more than 7 wrinkles above their eyebrows? You know, whatever it is, there's different steps. And at each point you got a yes or a no, or a 3 or a 7 or whatever it is, and you go down a different chain. So they had this, but not for patients, of course. It was for machines, and it was for manuals. And so they would create these trees, and these trees were readable by non-developers. And that was really valuable because they could show it to somebody who actually understood the machine and say, yeah, this is a real good tree, except you missed what happened if there's a blue error on a Friday. You know, if there's a blue 57 light turning on, you got a bigger problem. You got to read a different part of the manual. So they would update the tree and they would change it. So there's all this stuff that you can do that's actually a really valuable activity. It's really, you know, pays off very quickly to invest in making your code readable. And I've just given you a bunch of different ideas. I hope those are helpful. Lucian, I hope I covered your question, but I'm very happy to come back to it. If you're watching on the recording, of course, put your comment on the forum, and I'm happy to look at it there. Jessica brings up a very important point. Jessica is both a non-coder and a coder. She's one of these people who does both. And she says, what should I find in the README when I read code? Now, some of you might not know what I'm talking about when I say the README. When you write a piece of code, when you write a section of code, a really good practice is to write down what the code is supposed to do. Now, I like to make that automated and executable. So you got documentation that's always up to date. I talked about that before. But the README tends to be a more logical guide, tells you the strategy. Why are we doing these things? Why do we require passwords to be of a certain length? Why do we not allow people to reset their password more than twice a day? Whatever it might be, whatever the test is doing, whatever the code is doing, the README should explain that. You know, when I look at code, and I do this a lot for these evaluations that I do, what I'm looking for in a README is, can I get to grips quickly with where in the code to look? What piece of the code does which thing, and why is it doing that? If I can get those 2 questions answered, I'm in pretty good shape. There's no special format the README needs to be in. README just means a particular file whose title is README, and it says, read this before you start using this piece of software. It's going to give you a guide to how it works, where to look for bombs and problems and things that you might want to do, and why does it do what it's doing. So I hope that's helpful, Jessica. Those would be my 3 key questions that you should cover in any introduction to anything, really, whether it's code or a novel or something else. You want to know how it does what it does, why it does it, and where to look for problems. Right? If you can do that, you're in pretty good shape. Right. Let's look at another question. We've got Danielle who says, what about the testing pyramid? Are we going to go into reading all the different kinds of tests, or just automation like Cypress or unit or integration or something else? Great question. I'm really glad you asked that, Danielle, because you're going to encounter this if you're a non-coder and you don't know what Danielle's talking about. Don't worry, I'm going to explain in a second. But if you're that kind of person, you might go off to your engineers and say, I want to read the tests. I really want to read them. It's so exciting. And they'll say, which tests? And you'll go, I don't know. Squirrel just told me to read some tests. Can you show me the names? Focus on tests that have business meaningful results. Typically, those are going to be unit or integration tests, and I'll give you the very crash course in that you don't need to know very much. Unit tests test tiny little pieces. So we were looking at a unit test before in the narrative style, where we were adding 2 + 2 and getting 4. That's a very small part of what a calculator does. And it's just the part where you get numbers on the screen and you get an output out. It's not the part where the calculator might print out, you know, a little strip on those old calculators that would print out so you could take it with you and say 2 + 2 is really 4. Look, the calculator says. It doesn't deal with the on-off switch. It doesn't deal with the memory of the calculator. It doesn't do a bunch of different things that are how you bring the pieces of the calculator together. Guess what? Those are integration tests. So it's going to depend on your situation, which kind of tests from the testing pyramid, and there's more that I'm not even mentioning here, like scalability tests and other things. It's going to depend on what your expertise is, what you're looking for from the tests, and what you want to read. They should all be readable, so there should be no tests that at least don't have meaningful names that an engineer could guide you through. But which ones are you going to be interested in? I'd start with the unit and the integration tests. And if you seem to be looking at tiny pieces and you can't figure out where the system is or what these are for, you're like, it does a tiny little thing. We're just checking, one number in one report. We have loads and loads of data. Then you're probably looking too granular. You should look at the integration tests. If you say, wait a minute, I need to get into the detail. I need to know, if this is true and that's true, and the moon is in Pisces or whatever, then I need to make sure that I'm looking at the unit tests. I'm probably looking at too broad, too coarse a level. So Danielle, I hope that was helpful. It's an excellent question. And I think I'm going to take one more and then bring us together for some of the final ideas. We got Will, old friend of mine. Will has some really good insights and a real pleasure to work with. He says, what objections do you hear from engineers about non-engineers reading code, and how do you overcome them? Will, you're great because you always have these interesting challenges, and you put them very well. So I appreciate that you bring interesting difficulties to the fore, and you're pointing out a very good one. Some engineers are going to say, get the heck out of my code. You don't know what you're talking about. Will, leave me alone. You're not a coder, so, what are you doing in my code? Those are really reasonable objections. They're ones to overcome. So let's talk about that. If the engineers say, look, Will, you really can't understand what this software does. There's no reason for you to be looking at it. It's very abstruse and complicated, and you're just going to distract the engineers. Then you, I would recommend, should respond. You need to make sure that you are accountable to the people who are paying the salaries. So we need to find a way. I can help you, but it's ultimately your responsibility to make sure you can render an account of what the value is of this software that you're creating. And at whatever level people need to look at it. So you get engineers who will say things like, oh, we have a very complicated containerization process, and we use Kubernetes to do this and that and the other thing. And you look at it, and what they're actually trying to do is save a bunch of money, and the company is not trying to save money. The company is trying to expand rapidly. And so they're really misaligned. And when you get that misalignment, that means you have a dearth of accountability, and you need to fix that. So first objection I tend to encounter, Will, is somebody who says, look, you're not going to understand, and I can't explain it to you, and you should just trust me. Run the other way. And Will knows this, but I think some other folks might benefit from the reminder that if the engineers try to snow you and say, just trust me, I know that it's really valuable what I'm doing, but I can't tell you, don't trust them. That's not valuable. And so the way to overcome that objection is to steamroller it and to say, well, look, that's not the culture here. That's not how we work. That's not what we do. We are accountable. And notice I'm saying be accountable. One problem that I think is people confuse these terms. They'll say, I want to hold you accountable. And that makes me cower in fear. I hide under my desk. I go, oh my gosh, Will's coming to get me. He's pointing the finger. He's telling me that I'm going to be, he's going to hold me accountable. Whereas if I'm accountable to Will, then it's my job to come to Will and explain, here's how I'm spending your money. This is the value that you're getting. And if you look at some of my other stuff, you'll see that you can actually provide that validation, that information really frequently. Frequently, as often as every day, you'll know the developers did this yesterday, it's got this value, and I know what they're going to do tomorrow. If you have that level of steering and confidence and knowledge based on having read the code, based on having understood what the engineers are doing, yeah, that's really, really powerful for keeping the engineers on track. And guess what? Making them insanely profitable, which is our goal in the squadron. Let's see, do I have any other objections that I often hear? The major other one I dealt with briefly before, but Will, I'm going to remind us of it because it's so frequent and it's really important to overcome. The engineers will say something like, I don't have time to write tests. You want this feature done by Friday. If I write tests, I'll go slower. They're wrong. If they write tests, they'll go faster. If they skip the tests, they'll go slower. Because what they're doing, of course, is crafty accounting there. They're saying, oh, great, yeah, I'm going to skip the tests, but then when all the bugs come in and all the things don't work, I'm not going to count that. I'm going to say, look, I delivered on Friday. It was full of bugs and it didn't do what you wanted, and we didn't have any feedback or accountability, but here it is. That doesn't make anybody very happy. That's not an output that's very good. It doesn't lead to the right outcome. So First of all, if they say I'm going to skip the tests, just tell them to stop right away. Have them phone me. I can give them a very long list of reasons why that's a really stupid idea. But you might also have engineers who say, look, we're writing tests. We understand that makes us go faster. It's really valuable. It's really good. We have some nice QA people. They look at the tests. We have some nice product managers. They look at the tests. If you ask, the CFO or somebody in operations or sales or something to come and look at our tests, we're never going to get anything done because you're just going to be sitting here with us going through all this stuff all the time and telling us things that we already know. Now, that's a more valid objection than the first couple that I referred to. It's still wrong. And the reason is that you don't necessarily have to have a parade of different people coming and reading the tests. You could have one person, you could have a proxy, or you could do it make a video of it. There's lots of ways to solve it. But just like you would certainly want somebody to be checking that the salespeople are actually selling something at the right price point, that they're agreeing on the right contracts. I hope somebody in legal is checking the contracts. I hope somebody in finance is checking the pricing. If not, you're in a lot of trouble. Just like you want those people doing that kind of check, and they do it in an efficient way, right? That you don't have everybody checking pricing, but you sure as heck have somebody in finance going, yes, this is the price we agreed. It's more, the price is higher than the cost. Therefore, we're going to make a profit. I hope somebody's doing those kinds of checks for you. In the same way, you want your engineers to be accountable and for you to be able to do tests and to verify that they are actually doing the thing you're expecting them to do. So the objection, hang on, it's going to distract us. It's going to take too much time. It'll be too complex, is valid in the sense that maybe there's something you could, a way you can consolidate, make it more efficient, but do not drop it. Just like, you might have somebody in finance saying, we're doing double entry bookkeeping. Really inefficient. We write down everything twice. What a stupid idea. We're going to go to single entry bookkeeping. No debits and credits. We're just going to write it all down once. That's a good way to go bankrupt, right? Or to get embezzled. So in the same way, you want to make sure your engineers are creating a system of credits and debits, checks and balances, that they are then accountable to you in an efficient way for what that looks like. And that's where product managers are hugely valuable. Account managers are often highly valuable. Even customers themselves can come along if you prepare it for them well. You can show them tests, code, behavior, demonstrations of the software, and get tremendous feedback from them saying, hang on a second, this isn't built right. And I just want to tell one story quickly related to that. Stephen says, when you work with scripted languages, it's always faster to write the test. Stephen, it's always faster to write the test in any language. If you're writing a horrible language that doesn't support tests, that'll force you to stop using that language. So I really feel strongly about this, if you can't tell. But I do want to tell you just one fun story before I close. And that is, I had a financial software product that we really weren't sure how to test. We weren't sure what it was supposed to do because it was so complex, and the mathematics and the accounting that we had to do to make sure that it was providing the right outcome and the traders could actually trade and make money. We really didn't quite know what it was supposed to do, but we didn't worry about that. What we did is we created a web page, and on the web page, we typed in a bunch of numbers. We just typed them in. We didn't try to calculate them or anything. But if you've ever seen the screen of a trader, they usually have 8 screens, surrounding them, and they're on 3 phones at the same time. It's that kind of Wall Street, London City kind of setup. They have tons of numbers on their screen. So we just typed in a bunch of those numbers, took a photo, said, this is what it looks like. And we showed it to them, and they said, well, this one's wrong. That's a tremendous skill of these traders, that they can look at a bunch of numbers and say, that one's wrong. And I said, that's a screenshot of your screen. Like, oh, our system has a bug. I said, yes, it does. So our new system was going to not replicate that bug because we found out about that number. Then we replaced that number with the correct number, calculated from all the other numbers, which were typed in, right? They weren't really there. And then we went back to that user and we said, hey, did we fix that number? And the user said, yeah, but these other numbers, they're wrong. We said, that's also from your system. Let's figure out what's going on there. Oh, actually, this one's right, but you need to make it bold or whatever. We got all kinds of feedback. And we gradually replaced all the different numbers with actual numbers computed by the system. And the result of that was that we went live on time and customers loved it. It was a very successful project of replacing an old system that did some stuff wrong with a system that did the right stuff. And we did all of that by having non-coders. In fact, people are very impatient. If you've ever met any city traders, they're not known for their comportment and their calmness. So these were folks who didn't have much time, but they could go, wrong, right. Okay, see you next week. and we could continue to iterate and improve. So that's a way to look at the tests, look at the example results in this case, and get tremendous feedback that allowed us to make a huge profit. So that's what I'd recommend you do, is get your non-coders, if you are a coder, to come in, join you, sit next to you, look at the code together, read at least the names of the tests, and make sure that you're doing the right thing. If you're not on the coding side, I implore you, I beg you, I urge you, find yourself an engineer, sit down next to them and say, I'm overcoming my fear. I'm a codophobe, but I'm trying to recover. Help me, show me some tests, tell me what these tests do, and I'm going to apply my domain knowledge to giving you feedback about how you could do the better, what you could test. Is the system doing what you expect it to do? I hope that's really valuable to you. It's certainly been very valuable to my clients, and I've had a fun time talking to you about it. Back next week with another Squadron event. I believe that one, it slipped my mind which one it is. Have a look on squirrelsquadron.com. You'll see there's a bunch coming up. And the most exciting one coming in the 1st of May is a live event in London, which is all about why you should delete Slack, cancel meetings, get yourself a whole lot more time every week. That's what I teach my clients to do, and they gain at least a full 8 hours every week. You can do that too. Join me in London for that. Join me for further events that are coming up this month and next. You'll find them all on squirrelsquadron.com, and go and read some tests. Have a fantastic day, everybody. Really glad to have you. Thanks.